Ernest Rutherford is a physicist born in 1871 in New Zealand. He started his academic journey at University of New Zealand and further his study at University of Cambridge. Rutherford is known as the father of nuclear physics and he is a pioneering experimentalist in atomic nuclear physics. In 1908, Rutherford received the Nobel Prize in Chemistry for his work on the disintegration of elements and the chemistry of radioactive substances. He also identified the alpha and beta. In 1909, he conducted the famous Goldford experiment and led to the discovery of neutrons in 1911 and discovery of proton in 1917.
One of Rutherford's biggest contributions to quantum science was discovering the atomic nucleus in 1911. His Goldford experiment showed that atoms are not just blobs of charge, they have a tiny, dense center called the nucleus. Then, in 1919, he made history again by changing nitrogen into oxygen, proving atoms can transform into other elements. Finally, he identified the proton and predicted the neutron, which helped scientists build today's model of atom using quantum theory.
Ernest Rutherford's discovery completely revolutionized how we understood the atom. He disproved the existing plum pudding model and introduced the idea of a dense nucleus at the atom center. This breakthrough laid the foundation for nuclear physics and opened up new areas of research in radioactivity and atomic energy. His work also inspired the development of quantum model, and scientists like Bohr built upon Rutherford's finding to explain electron behavior in orbits. More importantly, Rutherford's discovery marked a major shift from classical physics to modern atomic theory, which later influenced fields like medicine, chemistry, and even the early stages of nuclear technology.
This relevance thanks to Rutherford for founding of proton therapy. Second, Rutherford backscattering spectroscopy, mainly used as semiconductor industry, nanomaterial, and forensic and archaeology. The RBS is directly based on Rutherford alpha scattering experiment, making it a modern tool for his original nuclear work. Lastly, nuclear physics and reactor physics. Rutherford's legacy spread widely in nuclear science, from nuclear reactor to the understanding of nucleus and proton. Nowadays, this apply our research into next-gen nuclear reactor and clean energy alternative using clear physics.
I would like to present about contribution to quantum chemistry by Ernest Rutherford. First thing first is the foundation for electron orbital theory. Rutherford led to the quantum mechanical explanation of electron distribution, atomic bonding, and molecular shapes. Next is the influence on the Bohr model. Niels Bohr, which is his student, used Rutherford's finding to develop quantum atomic model. It was a cornerstone of the quantum chemistry. And lastly, research in radioactivity. He discovered alpha and beta radiation, and the atoms can transmute to the other elements.
How Ernest Rutherford's findings influenced their era. Ernest Rutherford's discoveries completely changed how scientists viewed the atom in the early 20th century. In 1911, he introduced the nuclear model after the Goldford experiment, showing that atoms have a dense nucleus. This overturned the plum pudding theory. His model directly influenced Niels Bohr, leading to quantized atomic models and the early development of quantum mechanics. In 1917, he performed the first artificial nuclear reaction, marking the birth of nuclear physics. He also introduced the concept of radioactive decay and classified alpha and beta radiation, ideas that quickly found use in medicine and chemistry. Lastly, through mentoring future Nobel Prize winners and leading the Cavendish Laboratory, Rutherford built a scientific legacy that shaped modern physics.
Here is the slide for Ernest Rutherford's legacy in modern science and technology, but I will focus only on discoveries that were directly made by him. Ernest Rutherford's legacy is remarkable and lasting. He discovered the atomic nucleus and proton, laying the foundation for nuclear physics. His radioactivity research led to PET and gamma scans, while Rutherford backscattering spectrometry is still used in material science. His nuclear work also helped pave the way for energy development. These contributions continue to influence science and technology today.